On the left hand side, we can actually rewrite it into argument of w conjugate plus the argument of w to the power of n. And argument of w conjugate, we can reference it to the argument of w. So here it is going to be minus of the argument of w, which is minus pi over 4, plus the argument of w to the power of n is pi over 2, which means that the argument of w to the power of n is going to be equal to pi over 4. But since n can vary, that means argument of w to the power n need not just be pi over 4, but it can be pi over 4 plus integer multiples of 2 pi. So I'll let it be pi over 4 plus 2k pi, and k has to be an integer value. So what I have now is n, the argument of w is going to be pi over 4 plus 2k pi, and the argument of w is minus pi over 4, which is here pi over 4 plus 2k pi, which means that the form of n is going to take up an expression of minus 1 minus 8k, where k is an integer value. And if I were to let k be, let's say, 1, so one possible value is when k is 1, n will be minus 9. And if k is 0, then n will be minus 1. If k is minus 1, that means n over here is going to be equal to 7. And if k is equal to minus 2, then n over here is going to be equal to 15. So n can adopt a lot of different values, but since the question asked me for the smallest positive whole number of n, that means n is going to be equal to 7.